Welcome. In this video, I'm going to be showing you how to solve linear equations. The learning target is to understand how to solve a literal equation. The success criteria is you can apply inverse operations and substitutions to solve for a literal equation. First of all, I would like you to already know what you're supposed to be doing, and up to this point, you should already know how to solve for an example, the area of a triangle. It starts off with the formula. So we write A is equal to 1/2 base times height, which is the formula for the area of a triangle. The second step is to make the substitution here. B equals to 6 because that is the base, and the height, which is 7. This is just labeling your step, then you're going to substitute it. The B here is replaced by the number 6 because B equals to 6. And the 7 here goes into here because it replaces the H. Likewise, now you can multiply 1/2 times 6 times 7, it gets you 21. Here, you actually solve for the area of the triangle by saying in the end, the area is equal to a numerical value. This is called an exact solution because there is a numerical value for what the area is. So the question is this: what happens if now you're asking to solve for the height of the triangle? Here, the area is equal to 1/2 base times height, which is the general formula. And here you're trying to solve for H because it says solve for H. And again, the goal is to get H alone. To get H alone, first of all, we have to get rid of the 1/2 by using the inverse property. 1 divided by 2, to get rid of that, you multiply by 2. Once I multiply by 2, that's how I get 2a on the left hand side, and on my right hand side, the 1/2 times the 2 cancels out, leaving you with BH. H is not alone here. H has a B that is attached to it by a mathematical operator of multiplication. To get rid of that, now you divide. So you're going to divide by B, divide by B. Okay, that is how they got to the last step. H is now solved for because it is alone. But H is equal to 2 times the area divided by the base. Here we say that H is solved for, but this is not an exact solution. This is called a general solution. This works for any scenario. The fact that if you know that the area and you know the base, you can find the height using this general solution. To get any general solution for a literal equation, we have to remember our list of algebraic operators. For example, if you have the equation of A plus B plus C is equal to R, big R, and they're saying solve for A. Well, you have to get rid of the B and the plus C. So you would subtract B from both sides, getting you A plus C is equal to R subtract B. Then you also want to subtract the C to get A alone. Get you R minus B minus C. Notice, I apply the inverse operator. The inverse of addition, to get rid of the plus B, I subtracted B. Okay. Likewise, if it was a subtraction, for example, big R subtract S subtract T is equal to little a. Here, how do you get rid of the big S? So add S, get you R minus T is equal to A plus S. Add T, get you R is equal to A plus S plus T. Likewise for multiplication, you might see it like this. P is equal to VT. This is stuck together by multiplication, but they don't show the dot. They just write the terms together. To get rid of that, you would have to divide. So let's say you're solving for T. So divide by V, divide by B. You would get T is equal to P over V. Likewise, if you have already a division, let's say L is equal to S over V, and you're trying to solve for the S. So here, to get rid of the V, you would multiply by the inverse, which is V over 1 times V over 1. So do you see how the divide by V, the inverse of that is the multiplication of that, because this cancels out, getting you VL is equal to S. Likewise, the square root and the squared. Sometimes you might see something like K is equal to MV squared, and you're trying to solve for the V. What you need to do first here is, I would get rid of the N. So I would divide by N, divide by N. I will get K over N is equal to V squared. Now to get V alone, square root, square root. This cancels out. So I will get V is equal to the square root of K over N. Likewise, you might have something like T is equal to the square root of L over G. Okay, and they're saying how do you solve for the L? Okay, first of all, you have to get rid of the square root, right? So you're going to square both sides, because again, these are inverses. So square this, you get T squared is equal to the squared and the square root cancels out, getting you L over G. Now to get L alone, you multiply by G, multiply by G. So G T squared is equal to L. There you go. Here I'm going to give you a complete example of how to solve for a literal equation. You could try it because I gave you multiple examples before. I'm going to now solve for V. First of all, I have to get rid of the 1/2, the inverse operator of that. So I'm going to write the problem out first. And I'm trying to get rid of the 1/2. So here I'm going to multiply this by 2, multiply this by 2. Get you 2K on the left hand side. The 1/2 and the 2 cancels out, getting me MV squared. I want to deal with the M next because I want to leave the V for last. So this is attached via multiplication. So the inverse of multiplication is division. So divide by M, getting you 2K over M is equal to V squared. Now the V squared, how do you get rid of a squared? The inverse of that is the square root. So square root here, square root here. This cancels out. The square root and the squared cancels out. So get you V on my left hand side, get you the square root 2K over M. There you go. This is completely solved for. On the AP Physics formula sheet, you're going to see different terms. And I want you to understand that these are actually different. In reality, V plus V equals to 2V. That is correct. But here, let's say it was V plus Vx. You can't add these two. These are different. Okay, these two is not equal to 2V. These are different. This and this are different. Okay, because of the subscript x. Here, same thing. This one, V, Vx, Vx squared are all different. Okay, the only one that is the same is this. This one and this one are the same. This one is just squared. So this is just squared. Okay. So be very familiar with the subscript. So in physics, during the year, I'm going to explain what these are. So this is velocity. This is velocity in the x. See how this is different? This is velocity in x starting. So these are different variables to represent different things. That's why it's different. Here you see t. T mostly stands for time. This delta that is attached to the t, this does not mean time. This means change of time, which means this is tf minus ti. So what I'm trying to tell you here is that these are all different terms, so don't group them together. Lastly, I'm going to show you how to solve for a literal equation with substitution. Here's the problem. Vx is equal to Vx naught plus Axt. Solve for t, given that Vx naught equals to 0. You could try it if you would like. First of all, I'm going to rewrite the problem. I always rewrite the equation. So that's how it is. Now it says V naught x equals to 0. So make that substitution. So Vx is on the left-hand side. V naught x was 0. That's what it says. So that becomes 0 plus Axt. Do we even write the 0? No. Okay, so it really looks like Vx is equal to Axt. Now solve for t. Well, divide by Ax, divide by Ax. What does that get you? Vx divided by Ax is equal to t. There you go. You solve for t. Okay, this is the substitution step. Then the rest of this is solving for the general solution. This is a general solution because you can solve for any t if you have the v in the x direction and the a in the x direction. Okay, there you go.